this video, we'll look at how to solve a system of two equations using the Gauss-Jordan elimination method. The goal in this method is to get the same coefficients in front of one of the variables, except we want one to be positive and one to be negative. Just for tracking purposes, I like to label these equations as equation number 1 and equation number 2. Particularly when we use the same method to do three equations with three variables, this helps me to keep track of where each equation came from. Now again, we want the same coefficient in front of either the x's or the y's. It looks like it might be a little bit easier for us to get the same coefficient in front of the y's if we multiply the first equation here by 2. And again, I'm just kind of tracking what I did, so I'm going to use this notation to show that I'm going to multiply this entire equation by 2. So I'll get 6x plus 4y equals 6. We're going to leave the second equation alone because it already has the negative 4y in front. Now we're going to add the two equations together. We get 6x plus 2x gives us 8x. Plus 4y minus 4y equals 0, so the y's go away completely. That was the whole purpose of getting that same coefficient in front of the y's. Now 6 plus negative 14 will give us negative 8, and then we can divide both sides by 8 to get that x is negative 1. Now, in order to find y, we'll have to go back to one of the equations. And it really doesn't matter which equation you want. I'm going to use equation number 1. And I'm going to substitute in negative 1 for x. So I've got 3 times negative 1 plus 2y equals 3, giving me negative 3 plus 2y equals 3. And now you can solve for y. So we'll bring the 3 over to the other side, giving us 2y equals 6. And we can divide both sides by 2 to get that y is 3. So we know that our answer, our solution to this system of equations is negative 1, 3.